Welcome to This Explainer. Today, we're stepping right into a beautiful fairy tale realm. But, we aren't going to find wizards casting actual spells or dragons hoarding treasure here. Instead, we're on a quest to uncover mathematical illusions that are hiding in plain sight. You're going to quickly discover that once you understand the underlying principles, those seemingly impossible calculations you run into are really just clever acts of logical sleight of hand. So, imagine a kingdom where the quote-unquote magic comes entirely from brilliant math and strict logic. The cobblestone streets are literally paved with numerical puzzles. And to be absolutely clear, there is no supernatural power at play here, just breathtaking shifts in perspective. It's exactly like watching a grand illusionist trick on a stage. Once we see through the misdirection, everything becomes wonderfully clear. Are you ready to be an explorer in this kingdom? Let's dive in.
All right, let's jump into Section 1, the wondrous coin game, positive versus negative.
Our very first stop brings us to the bustling central market of the kingdom. Here, weary travelers love to play a very specific game with gold coins. And honestly, this turns out to be the absolute best way to understand positive and negative numbers. See, in this realm, there's a fundamental law of wealth. We use +1 to represent you receiving a shiny gold coin and dropping it straight into your pouch. Nice and easy. On the flip side, -1 isn't some dark, forbidden thing. It simply means that someone has borrowed a coin out of your pouch. That is the absolute purest meeting of positive and negative. And this simple rule perfectly sets up our first grand illusion. Imagine you just received one gold coin. Bam, that's a +1. But in the very next second, someone instantly borrows one coin from you. That's a -1. What happens to those two actions? Well, they perfectly cancel each other out. Your pouch is instantly brought back to absolute zero. It's a pretty marvelous disappearing act of addition and subtraction, right? Now, the real trick here is how we can actually use this to solve seemingly complex math. Let's say we need to figure out 3 plus -2. Just imagine your pouch starts with 3 gold coins. Then we add -2, meaning someone borrows 2 coins from you. We already know a positive and a negative perfectly cancel each other out, so those 2 borrowed coins cancel out 2 of your original coins. And presto, the illusion is revealed, leaving you with exactly 1 coin. So subtraction, it's really just adding a negative number. Moving right along to Section 2, the chef's delicious cakes, secrets of fractions. Leaving the market behind, we're going to head straight to the fragrant royal kitchens. Here, the head chef's incredible baking skills give us the perfect canvas to completely deconstruct the mystery of fractions. Take a look at this freshly baked, mouth-watering cake. The chef has expertly sliced it into exactly 5 equal pieces. If you take one of those pieces, in the language of mathematics, you haven't just taken a fixed random unit, you've taken 1/5 of that whole cake. A fraction isn't just an isolated number, it's a really brilliant way to describe a relationship between a part and the whole. But hey, today is the kingdom's grand festival. The royal chef hasn't just baked one cake, he has shown legendary stamina and baked a staggering 80 glorious cakes. The entire kitchen is just overflowing with desserts for tonight's feast. And here is where a classic storybook dilemma pops up. Let's say a very hungry traveler sneaks into the kitchen in the dead of night. He doesn't just eat 1 or 2 cakes. This guy manages to eat 3/20 of the entire feast. So the big question is, when you're faced with a massive number like 80 cakes, how on earth do you figure out exactly how many physical cakes make up 3/20? Well, the secret is that fractions are just a proportion illusion. The crucial first step is to view all 80 of those cakes as one giant single collection. Next, we look at the bottom number of our fraction, the denominator, and mentally divide that giant collection of 80 cakes into 20 equal parts. Since 80 divided by 20 is 4, that means each part contains exactly 4 cakes. Then you look at the top number, the numerator, and we simply take 3 of those parts. We have 4 cakes per part, and we are taking 3 parts. And just like that, the answer reveals itself. 4 multiplied by 3 is 12. This ravenous traveler somehow ate 12 entire cakes in the middle of the night. I mean, isn't that a remarkably clean piece of mental sleight of hand? By cutting up the whole and multiplying by the proportion, that intimidating, ugly fraction instantly transforms into 12 concrete cakes, safely leaving 68 cakes behind for the rest of the festival. Let's head over to Section 3, the mysterious box trick, mental math magic. Stepping out of the kitchen, we arrive right in the kingdom's central square. A massive crowd has gathered because the grand illusionist is about to demonstrate his incredible mental math prowess. He's using a trick we formally know as the distributive property. The illusionist throws down a challenge to the crowd. Can you instantly calculate 32 times 34 plus 68 times 34 right in your head? If you try to calculate the left side first and then the right side, your brain will probably tie itself in knots. But the illusionist? He produces the correct answer in the blink of an eye. How is that even possible? Let's break down his misdirection. Look closely at those two multiplication problems. Do you see the shared element there? It's the number 34. The trick is to just imagine that repeating number, 34, is safely hidden away inside a mysterious wooden box. Now the whole problem completely changes. You have 32 boxes, and you're adding 68 boxes to them. Add those together, 32 plus 68, and you have exactly 100 boxes. For the grand finale, you open the boxes by multiplying that super easy 100 by the hidden number 34. Multiplying 100 by 34 is an absolute breeze. The answer is an astonishing 3,400. By looking for those hidden boxes, or, the shared factors, we took an incredibly intimidating string of multiplication and turned it into simple addition and basic multiplication. That is the sheer power of the distributive property, and it makes complex mental math feel like an actual magic trick.
Finally, Section 4, Percentage Transformation Trick, Fractions in Disguise.
For the final leg of our journey, we're stepping into the grandest building of them all, the Great Exchange. This is a place where numbers shapeshift seamlessly between fractions, decimals, and percentages. Right above the doors, there's a golden rule engraved. Percentages are just fractions in a brilliant disguise. And that perfectly captures the fact that whether you're looking at a percentage, a fraction, or a decimal, they are all ultimately just different masks worn by the exact same value. Never let the fancy mask of a percent sign intimidate you. So, to see past this disguise, we just use the exchange's simple currency rate. The core of this transformation trick revolves around the number 100. To turn a decimal into a percentage, you just move the decimal point 2 spaces to the right, which is literally just multiplying by 100. So 1.0 multiplied by 100 becomes 100%. If you have 0.5, shift that decimal 2 spots to the right, and it morphs into 50%. Even a larger number like 2.5 transforms effortlessly into 250%. And what makes this trick so incredibly powerful is how quickly we can chain these transformations together in daily life. Imagine a coin chopped in half. One half instantly transforms into 50%. 1/4, which is like dividing 100 by 4, shapeshifts right into 25%. 1/5 slides perfectly into 20%, and 1/10 magically becomes 10%. Once you master this rule of 100, you can rapidly switch these numerical masks right in your head without breaking a sweat. But wait, what happens when we encounter an illusion that goes over 100%? Well, don't panic. It just means we're adding to the original whole. Let's say the baseline for an item is 20 gold coins. That 20 coins is our 100%, right? If someone asks you to find 120% of those coins, it's a simple trick. 120% is just 100% plus an extra 20%. The 100% is 20 coins, and 20%, or 1/5, of those 20 coins is 4 coins. 20 plus 4 gives us exactly 24 gold coins. The logic holds up flawlessly every single time. From canceling out gold coins in the market, to slicing up proportions in the kitchen, calculating hidden boxes in the square, and shifting disguises at the exchange, we have really seen it all today. In this kingdom of numbers, math isn't some rigid set of boring textbook rules. It is a series of brilliant, perfectly logical illusions. And once you see the mechanics behind the trick, you become the master of the numbers. So when you step back into reality today, where will you spot the next mathematical illusion hiding in plain sight in your world? Keep that curiosity alive and keep exploring.